See, it shouldn't take this long. It's not
There
good.
you go.
Okay, so the methods we've used to solve quadratics so far are if you have an x squared term but you don't have an x term, you get your square term by itself, all your constants on the other side, take the square root and solve. Or if you had an x squared term and an x term, we use guess and check and factor it, then set each factor equal to 0 and solve, right? What you're going to be doing today is another method, which it's useful when we have to take a quadratic and put it in what's called vertex form, okay? The only way that you can put it in vertex form is to do this method. So this isn't necessarily a method I would normally use to solve a quadratic equation, but some people prefer it over all of the other methods because just like using quadratic formula, you can always use this method, okay? Quadratic formula is another one where you can always use it. But you can always use this completing the square. And so, first of all, when I'm talking about vertex form, I'm talking about this. Y equals, now we looked at intercept form, right? Intercept form, x minus p times x minus q, remember? Y equals x minus p, parentheses, times x minus q, parentheses. That was intercept form, right?
Yeah.
Thank you. So vertex form is y equals a times x minus h squared plus k. That's vertex form, okay, where you have a binomial squared. A is just that number that you could have possibly factored out in the beginning, your greatest common factor. A determines whether it's reflected or not, okay? A also determines whether it was stretched or compressed. H and K represent your vertex, okay? I told you guys all of these quadratics form a parabola, all right? Your vertex is your highest or lowest point. So that would be the point H and K. And what we're going to have to do at the end of this lesson is you're going to have to take just a regular trinomial like this, that's a quadratic, and you'll have to put it in vertex form. So to get it to this form, we have to do this process, okay? Well, we know how to take a trinomial and factor it. So we're going to factor this using guess and check. Okay? So what's my first terms?
X minus
X and X, right? So what times what's 36? 6 and 6, right? Positive 6 or negative 6?
negative because it's first line.
Good, they both have to be negative. So I got the same thing. Now, if I checked it, I would get negative 6x and negative 6x, which gives me negative 12x. That's correct, right? So since it's the same thing twice, I can write it as what's called a binomial squared. So x minus 6 squared. That would be one. Look forward a little bit. That would be my x minus h squared. Okay? So let's do this for all of them. And what we're going to look for in a minute is we're going to look for a number pattern. Okay? So x squared plus 10x plus 25. We're going to factor that. My first term is
X.
x and x. That's my first term, yes. And then 25 is what and what? 5 and 5, positive or negative? Both positive, because my middle term has to be positive. So we got the same thing twice again. So that equals x plus 5 squared. Now we're doing a bunch of these because I want us to start to notice a number pattern. Okay? Over here, what's the next one? We have x minus 14x plus 49.
X is
Going to be x and x.
minus 7.
Minus 7, minus 7. Check it. Negative 7x on the inside, negative 7x on the outside gives me negative 14x. So as a binomial squared, that's x minus 7 squared. Okay?
X.
So let's do the next one. X and x. And then plus 2 and plus 2. Inside gives me 2x, outside gives me 2x, combined that gives me positive 4x. So that's x plus 2 squared. Now, what I've given you, all of the trinomials on the left-hand side, they are called perfect square trinomials. okay? Perfect square trinomials, when you factor it, will give you a binomial times itself, which is a binomial squared, okay? And so let's do this next one. Again, x and x. Notice that for every single one of these perfect square trinomials, there's nothing in front of x squared. And all of the in front of x squared is just positive 1. That has to be the case for it to be a perfect square trinomial. For it to work out this way, you cannot have something in front of your x squared term. And it can't be negative. Okay? Now, what's this one? Factor this one. 12 and 12, positive or negative? Negative 12 and negative 12. Because when you combine those, negative 12x and negative 12x gives you negative 24x. So that's x minus 12 squared. Okay? And the last one.
Oh.
Good. Negative 10 and negative 10. So that's x minus 10 squared. Now, let's start to recognize what are the relationship between certain numbers, because you're going to be skipping this middle step, the factored step. Okay, when we start to solve these and we're going to create a perfect square trinomial. In that process, you go from this step directly to binomial squared step, okay? And I'll show you why in just a minute. But let's look at, first of all, our last term. This was a perfect square, so it's 6 times 6. 25 is a perfect square, 5 times 5. 49 is a perfect square, 7 times 7. Okay? So you have a perfect square on the front, perfect square on the back. What do you notice about the second sign?
Always addition.
Always addition. It has to always be addition, because when you multiply this term times this term, you're multiplying something times itself, it's always going to be positive, right? So when you multiply your last terms, that's why this is always positive. Now this can be either positive or negative in a perfect square trinomial. This first sign just determines what those are going to be. If this is subtraction, that's subtraction. Positive, positive, okay? So if we're going to skip this step, if we're going to go straight from this step to this step, my first term right here is the square root of my first term, right? My second term is the square root of my last term. And this sign right here is determined by that. Everyone see that? Everyone see that pattern? Okay. Now, how do you determine, what I want you to do is I want you to recognize what is the relationship between B and C. What is the relationship between B and C? If you had B, but you didn't have C, how would you go from here to here? What do they do from here to here? How does 12 relate to 36? How does 10 relate to 25? There's a certain something that happens to B that makes C happen.
You said that was 36.
How did you go from 12? What did they do to 12 to get 36?
I'm dividing by 3.
Well, that one they times by 3, but this one didn't times by 3. It has to be the same thing for all of them. See if we can figure it out. Yes? You're very, very, very close. Okay? See if you can figure it out.
Do they square? Like, they are?
Yes. Go ahead.
Like x squared.
They do something to this to end up getting that. Actually, they do 2 things to it.
They squared.
And then what?
Squared.
Yes. They divide it by 2 and then square it.
Good job.
So if you take this, good. Y'all both got it. Okay, so if you take this and divide it by 2, you get 5. And then square it, you get 25. So if you take 14 and divide it by 2, you get 7. And you square it, you get 49. Okay? So for it to be a perfect square trinomial, for it to work out nice and neat like that, that's going to always be the case. Okay? I didn't want to tell y'all that. I thought it would help you remember better if you figured out that pattern, that number pattern. So that's what makes this a perfect square trinomial. Okay? Perfect square on the front, perfect square on the back. You can't have anything in front of x squared. Okay? The last sign has to always be positive. If this is negative, this won't factor this way. It won't factor where you have the same thing times itself, because your signs would have to be different, right? And so, this is A is 1, B is whatever, C is right here. This is C, okay? I'm telling you that because in a minute, you're going to have to find that C. You're going to have to force a perfect square trinomial. Once we make our own perfect square trinomial, we can take it from here and write it like this so that we can take the square root of both sides. Okay? The whole point in this is to take a problem. Now, recognize this is my first one. X squared minus 12x plus 36, right? Okay. So, if I took that same problem, x squared minus 12x plus 36, and I put equal to some number, I don't care what it's equal to. Okay? I don't want to set it equal to 0, because if I subtract 16 from both sides, I'll have x squared minus 12x plus 20 equals 0, and then I don't have a perfect square trinomial anymore, right? So I'm showing you the purpose of what we're doing right now. This is a perfect square trinomial, right? Now I'm gonna write every step. Now, when we actually start working these, you're not going to put the second step. When I factor this, what does this factor to? Minus 6 minus 6, right? So I can write this as x minus 6 squared, right? This is the point of what we're doing. Now, I can take the square root of both sides and solve. This is what we did the other day, right? From here on down, we've already done this. From here to here, that's the new part, okay? And so what we can do now is we can take the square root of both sides. And so you have x minus 6 equals what? 4. Close. What did we forget?
Oh, you got a square root of the other side.
Well, we did, but what do we put here? That's half the answer. 4 is half the answer.
Plus or minus.
Plus or minus 4. Don't forget the plus or minus. So that's x minus 6 equals positive 4, and x minus 6 equals negative 4. Okay? Now we can solve. So x equals 10, and x equals 2. Okay? So, because this was a perfect square trinomial, we could do this. Does everyone agree? Okay. The other option would have been, like I said, subtract 16 from both sides, and then you would have had to use quadratic formula to solve it. But if you have a perfect square trinomial like this, you can write it as a binomial squared and then take the square root. That is the purpose of this. Okay? So, when you end up with a problem, hang on, is anyone not finished? Okay, so now let's look at this problem. X squared minus 12x plus 20 equals 0. Is that a perfect square trinomial? No. If you take half of 12, you get 6. 6 squared is 36. This is not a perfect square trinomial. Y'all agree?
Yes.
So, if I had to solve this, I could use quadratic formula. Guess and check will not work. So, I have to, well, it could work, but for this purposes, we're going to pretend like it doesn't. Okay, so, this is what I'm going to do. I'm going to make this be a perfect square trinomial. Now, I need the correct C, right? If I had the right C, then it would be a perfect square trinomial. Then I could do what I just did. Now, it's legal as long as I add something, as long as I add it to both sides, right? So this is what I'm going to do. I'm going to take this C that I don't like, because it's not a perfect square trinomial, and I'm going to put it on the other side. I don't want it. It's trash. It's not the right one. So, I have x squared minus 12x, but I'm going to leave a blank. I'm going to leave a blank, because I'm going to add my own C, and I'm going to make it. be a perfect, as long as I add the same thing to both sides, that's okay, right? So if I add something to that side, I have to add something to the other side. So first thing I did was I took the trash C and threw it over there. I don't want it. It doesn't serve my purposes. So now, what C should go here?
36.
Plus 36, right? If I had plus 36, that would make this a perfect square trinomial. Everyone agree? Half of B is 12. Half of 12 is 6. 6 squared is 36. So if I add 36 to this side, it's okay as long as I add 36 to the other side as well. Everyone agree? This is called completing the square. Yes? If I add 16 right here, this would not be a perfect square trinomial.
No, I got 16 to the 20 and 16 to the 0.
If I, well, that's still the same thing. This is still the same thing. I'm using the same example that we used a while ago so you could quickly see that. But sometimes there's fractions right here. They're not so quick to see that easy. But that would be okay. You would still be creating a perfect square trinomial. Okay? So this is a perfect square trinomial. So now, I told you we're going to skip that second step where we factor it. But until you get comfortable going from here to here, still factor it using guess and check. So you can make sure that you added the right C. Okay? So what is my binomial? Remember, we took the first term, take the square root, that's x. The last term, take the square root, that's 6. Is it plus or minus? It's minus because of that sign. So that's x minus 6 squared equals 16. So now we're at where we were in the problem that we just did before. Okay? Now, it doesn't always end up being a nice, pretty, perfect square over here on the right-hand side, because that would be way too easy if that was the case. Sometimes it's like 20 or 48, and you have to simplify that square root. Okay? Your answers aren't always real pretty. And so to solve this, we would go ahead and do what we did a while ago. Take the square root of both sides, and it would look just like the problem that we just did. Okay? So what we did right here was we, quote, completed the square. Because this was not a perfect square trinomial, but now it is a complete square, perfect square trinomial. Does everyone see that? Yeah? Okay. That is the general idea of this lesson. All right? The first set of problems in your homework, this is what the instructions look like. Find the C so that you have a perfect square trinomial. They just want you to tell them, what does C need to be for it to be a perfect square trinomial? That's all they want to tell you. That's all they want you to tell them. So we're trying to figure out what has to go here. Okay? So remember, and I added this, remember that C equals B divided by 2 squared. So if you take B divided by 2 and square it, that is what C needs to be. Yes. So half of 12 is 6. 6 squared is 36. So C has to equal 36. So that's all they want. A lot of students get confused for this type of problem because they think it's more complicated than it needs to be. They just want to know, find C. What does C have to be so that it's a perfect square trinomial? Okay? So when we look at this one, half of B is what? 10 squared is 100. So C has to be 100. Okay? Sometimes in your homework, it'll say find C so that you have a perfect square trinomial, and then write it as a binomial squared. Okay? So we found C. So if I actually put my C in, it would be x squared minus 12x plus 36. What is that binomial squared? X minus 6. Good. The square root of that. And what about over here? So this would be, if I put my C in, x squared plus 20x plus 100. So that binomial squared is 10, yes. Recognize that what goes right here, okay, that's our h in our vertex formula. That's always b divided by 2. That's just b divided by 2. Okay? So if you take this number and divide it by 2, that gives you that. Okay? Now, on the next page is the actual formal steps to completing the square. Now, we've already actually done it. We've completed those steps. So if you're a person that likes to have these steps written down, then write these steps down. Now, I have this equal to 0, but that could be equal to anything. It just has to be equal to another constant, another number. Step 1, make the ax squared coefficient equal to 1. In other words, if this was 5x squared, you'd either have to factor out a 5 or divide everything by 5. Because before you can have your perfect square trinomial, there cannot be anything in front of your x squared term. So that's why that first step is there. Step number 2, take your constant term and move it to the right. That's your trash C, the C that it doesn't work. You're going to move it to the other side. Get it out of the way. It's not perfect. It's imperfect. Step 3, find your C and add it to both sides. Find your perfect C and add it to both sides. Then write it as a binomial squared, and then solve by taking the square root of both sides. Do not forget the plus or minus.
I don't want to do that.
All right,
Does this involve my taxes?
not yet.
Sure.
Okay, so this says solve by completing the square. So we have x squared plus 8x plus 4. Now, you would normally look at this and go, I'm going to try guess and check. And it's not going to work. You're not going to be able to factor this using guess and check. Okay? But if you tried, you would only have 2 times 2 or 4 times 1, and neither one of those are going to get you 8x when you check it. Okay? And so, you could use quadratic formula, that would work, but I don't want you to do that right now. We're going to do completing the square. So, is that a perfect square trinomial?
No.
No, and I know that. This is a plus, that's good. There's nothing in front of x squared, that's good. But if I take half of 8, that gives me 4. 4 squared is 16, my C is wrong.
I have a question.
Yeah.
So, because I'm pretty sure you're going to move that forward to the other side. So instead of that, can we add 12? Can you do both ways? Like,
Sure. All right. So, take the one that doesn't work, move it over there. That leaves a blank, right? X squared plus 8x plus blank equals negative 4 plus blank. So, our C needs to be 16. Half of 8 is 4, 4 squared is 16. So we're going to add 16 to both sides. Now, this is a perfect square trinomial. So I can write it as my binomial squared. If you want to, you could factor it, and you would get x plus 4 times x plus 4, right? And that gives me x plus 4 squared equals 12. There's your 12. Okay? So now what? We're solving this. What do I do next? Why did I do that? So I can take the square root of both sides. That's the whole point of doing this. So I can take the square root of both sides. So square root of x plus 4 squared is just x plus 4 equals, that's plus or minus the square root of 12. Before I do anything, I need to simplify the square root of 12. 12 is what times what?
64.
Well, it is 6 times 2, but I want a perfect square.
4 times 3.
4 times 3.
So 2 times 3.
So x plus 4 equals plus or minus the square root of 4. Well, let me do that off to the side so I don't have to write so many steps. So the square root of 12 is the square root of 4 times 3, which is the square root of 4 times the square root of 3, which is 2 square roots of 3. Agree? So plus or minus 2 square roots of 3. Now I can write it my 2 separate equations. x plus 4 equals positive 2 square roots of 3, and x plus 4 equals negative 2 square roots of 3. The last thing I need to do is subtract 4 from both sides in both of those equations, right? I need to take this positive 4 and bring it on the other side so my x is by itself. Now, that's going to be a rational and then an irrational number. You always want your rational number first. So, x equals negative 4 plus 2 square roots of 3, and x equals what?
Under 4.
No, it's still negative 4 minus 2 square roots of 3. Okay? So here are my two solutions. I have one for y'all to try. Actually, yeah, one for y'all to try. Okay, so I want you to do this one. All right, so this is not a perfect square. 45 is wrong. And so we're going to trash it by putting it on the other side. So we have a squared minus 18a plus blank equals negative 45 plus blank. Half of 18 is 9. 9 squared is 81. On both sides, you have to do one side, you have to do the other. So now, if I factored this, it would be a minus 9 equals 36. So that's a minus 9 squared equals 36. So if you need to write this step, write that step until you start to recognize how to go directly from here to here. Okay? And so now we take the square root. So a minus 9 equals plus or minus 6. That was nice because it was a nice whole number. So a minus 9 equals 6. And a minus 9 equals negative 6. So we're going to add 9 to both sides. So a equals 15. And a equals 3. Okay? Any questions? Let's do another one. Anybody have any questions? Let's do this one.
Oh, no.
Oh, yes, yes, yes.
Hold on, so Kendall's girlfriend, your neighbor. Oh, yeah, sorry.
Okay, so the problem with this one is you have an n squared term and another n squared term. Those have to come together first. Those have to come together first. If one's going to jump from one side of the equal sign to meet the other one, it has to change signs, right? Okay. So take this one and bring it over there, and it becomes what?
N squared.
We have it when
Positive.
it comes positive 7n squared, and then it goes away over there, right? It's okay if I just do that? Okay? And so now you have equals 0 over there, and now we just have a positive n squared plus 14n minus 70 equals 0. Now, if something would have happened and this would have been a negative n squared, I would have had to divide everything by negative 1 to make that be positive first. It has to be a positive by itself variable squared. Okay? So if you had 5n squared, you'd have to divide everything by 5. You cannot have anything in front of your n squared term. Okay, so we get the 70 over because it's not our correct C. And so half of 14 is 7. 7 squared is 49. Now that's the right C. What you do to one side, you have to do to the other. And so if I factor this, that would be n plus 7 times n plus 7 equals 119. So that's n plus 7 squared equals 119. Then we would take the square root of both sides. So n plus 7 equals plus or minus the square root of 119, and that can't be simplified. So the only thing we have left to do is take the plus 7 and throw it on the other side, and it becomes negative 7, right? Okay? So n equals -7 plus or minus the square root of 119. Now, you may have it written -7 plus the square root of 119 and -7 minus the square root of 119. Perfect. Okay, so if at this step, if you didn't move the 7 over while it was still plus or minus, you may have left it as two separate equations, which is perfectly fine. Okay, now move this 7 over. So n equals -7 plus the square root of 119, and n equals -7 minus the square root of 119. Okay, or you could write it as a combined answer, plus or minus. All right, so we talked about vertex form. Vertex form is a times x minus h squared plus k. Now, they normally don't put h in parentheses, okay? I just put that so that I can clearly show you that when we pick out h and k, those are the coordinates of the vertex, the highest, the maximum, or the minimum point for our parabola, the highest or the lowest point in our parabola, okay? This is your vertex. So if you have, here's our parabola, these go on forever, so that's my vertex, okay? Or if it opens like this, the highest point, that's a maximum, that's my vertex, okay? The lowest point is a minimum. All of these equations right here are already in vertex form. What I want to do with you guys is practice picking out the vertex. Okay? Now, ultimately, at the end of this, you're going to put it in vertex form and then pick out the vertex. All right? Now, because the general form has a minus right here, when you're looking at this, we're going to do the opposite sign. Remember whenever we looked at how they transformed, how they shifted left or right? Remember? The number in parentheses with the x determined whether it went left or right, and it was always the opposite. This is why. This is why, okay? And so this number right here, added or subtracted to x, even though this is not a straight line, it's a quadratic, it still tells you the shift left or right. K still tells you the shift up or down. Okay, so later on when we talk about how did this move, you're going to be able to tell me, if it's in this form, you can tell me, only if it's in this form. Okay? So, the vertex is h and k. What is my vertex here? It's always the opposite sign that's in here is the x-coordinate. So it's what? +2, and your y-coordinate is -5. So my vertex is 2, -5. In here, A is 3, okay? So if I ask you, was this reflected? No, because this would have to be negative for it to be reflected, okay? But it is stretched, because A is larger than 1. But we're not talking about those, I'm just looking ahead. What is the vertex in the second one? What's my x-coordinate? The opposite, -7, and that's the same, +3. See this plus? That means same sign. See that minus? That means opposite sign. Okay? That means it got shifted to the left 7 and up 3. This got shifted to the right 2 and down 5. All right, what about the last one? What's my vertex?
8.
+8 and +4. It got shifted to the right 8 and up 4. And our second one was reflected because that A is negative. Oh, I just said reflection. This is a stretch. When A is larger than 1, it's a stretch.
But if it's negative,
Negative just means reflection.
okay.
The actual number, bigger than 1 or less than 1, meaning a fraction.
So what's,
If it's like 2/3
okay.
or 1/4, a number smaller than 1, disregarding the negative. See, this is 1, so it wasn't stretched or compressed. Okay, everybody understand how to pick out the vertex now? Okay, so now what we're going to do is we're going to take these, it says write the quadratic function in vertex form. And what is the vertex? So we're not solving, all we're doing is rearranging to put it in vertex form. But in order for us to do that, we have to complete that square. Because we need to write that binomial squared so that we can see this piece. Okay, and the only way to get it from a regular trinomial to where you have a binomial squared is to complete the square. So that is what this skill is most useful for. Okay? And so we have y equals 2x squared plus 8x minus 1. First of all, there are problems with this that make it's not a perfect square trinomial. First of all, there's something in front of x squared. We're going to have to take care of that. Okay? Second of all, once we take care of that, we'll see that this is not the correct c. That makes it a perfect square trinomial. So this is what we do. Step 1, take your constant and move it to the other side. Now, when we're writing it in vertex form, we're not going to get rid of this 2 as the first step. If you're solving, you would need to do that. But right now, we're going to take this constant and bring it to the other side. Now, in these problems, you have a y equals. It's going to leave it there. It's okay. It's not going to bother anybody. The very last thing we're going to do is take whatever is that we put with y, we're going to get rid of it. Okay? So I'm going to take this -1 and bring it over to the left. And what happens to it when I do that? It becomes +1. So we have y plus 1 equals 2x squared plus 8x. Okay? Now, I have to fix this problem. I cannot complete that square. I can't find c until I have nothing in front of x squared. So this is what you do. You factor out, what's my greatest common factor here? Just number-wise. Just 2, okay? 2 is what we need to get rid of. So we're going to factor out a 2. So we have y plus 1 equals 2 times x squared plus 4x, right? Now notice, what I factored out, that's going to end up being what? In my vertex form. That's a. What I factored out is a. Okay? Just recognize that. Okay, so now you might ask yourself, I don't know how to complete the square now with something in parentheses and something out of the parentheses. Well, it's the same thing. It's the same way. We're just going to complete the square with this. The rest of it we're not going to worry about right now. So, but still, the mathematical rules say if you're going to add something to one side, you have to add something to the other side. Right? Right? So, this is going to be 2, and then we're going to have to complete the square in here. X squared plus 4x plus blank. So if we're going to add something to the right, we're going to have to add something to the left also. Now it looks different because we're completing the square on the right instead of the left, but it's the same because they're equal. It's okay. Okay? My purpose now is to make this, find c, so that's a perfect square trinomial. Yes. Yes, it is. So what does c have to be? Pretend like that 2 is not even there. C has to be what?
4.
4. So we're going to add 4 here. But now be careful. How many did I actually add to the right-hand side? I didn't just add 4. I added 8. Because it is 2 on the outside, everything in here gets multiplied by 2, right? So I didn't just add 4, I added 8. 2 times 4, okay? So if I actually, in order for it to say balanced, you have to add the equal amount to the other side. Now, if I hadn't have factored out a 2 first, then you would just add 4 to both sides. But since I did, you have to multiply that times that number on the outside first, so that it stays balanced. You don't want your teeter-totter to be off, okay? And so now, just simplify this. So this is y plus 9 equals 2. Now, if you factored this, this would factor to what times what? X plus 2 times x plus 2, right? If I did guess and check with this, it would be x plus 2 times x plus 2. So that's equal to x plus 2 squared. We only have one step left, and then it's in our vertex form. Here's our vertex form. It's just y equals. It can't be y plus 9 equals. What do you think that plus 9 is in this? That's my k. So put that k back where it belongs over there. So y equals 2 times x plus 2 squared. Then what? Minus 9. It has to change signs. That is vertex form. Now, tell me, what is my vertex? Because that was the whole point of that. Very good. It's the opposite sign, -2 and -9. So that was a two-part problem. First, put it in vertex form. Second, tell me the vertex. Okay? I want y'all to do the next one. All right. So, bring this over there. So y plus 23 equals -2x squared plus 16x. Now factor out a -2. So y plus 23 equals -2 times x squared minus 8x. Now I'm going to go ahead and put the plus blank. Okay? And so we have y plus 23 plus something over there. Now, half of 8 is 4. 4 squared is 16. So we have to add 16. Now that's perfect. However, I didn't add 16 total on the right. I added 16 times -2, which is -32. That's where you guys are making that mistake. So you have y plus 23 minus 32 is y minus 9 equals -2, and this is x minus 4 squared. And then put your k back where it belongs on the other side. So y equals -2 times x minus 4 squared plus 9. And so the vertex is +4, +9. Okay, we have to find c that makes this a perfect square trinomial. Okay, how do we find c? We take b, we divide it by 2, and then we square it. And remember, we want everything to be exact. We don't want anything in decimal form, unless it started out in decimal form. So, what's b? 11, right? So, 11, you have to take that number, you have to divide it by 2, right? Divide it by 2. Don't actually divide it, leave it as a fraction, because it doesn't divide evenly. We don't want our answer as a decimal. Well, you could divide it by 2 and then change it back to a fraction to put it here, right? 11 divided by 2, and then we square it. How do we square a fraction? Square the top and square the bottom, right? What's 11 squared? What's 2 squared? So this is 121/4. It's b divided by 2 and then squared. That's what c is. b divided by 2 and then squared. Now, if I had to write that as my binomial squared, what's my first term going to be?
X.
X. Plus or minus? There you look at the sign. Minus. Leave it as a fraction. Remember, it's x plus or minus. What goes here? It's just b divided by 2. So it's just 11/2. If this was a 12, you would know that was 6,
12.
right? So if it doesn't divide evenly, just leave it as a fraction. Okay? X squared plus 10 thirds x plus c. We have to find out what goes there. Okay. We have to figure out what goes here. Now, the process doesn't change. You have to take b. What's b?
10 over 3.
10 over 3. You have to divide that by 2. So you have 10 over 3 divided by 2.
Oh,
Now, you have a calculator that can do that for you. But anytime you take a fraction and you divide it by 2, that's the same thing as multiplying times 1/2. Right? 10 divided by 3, 10 over 3 divided by 2. Right? So that's 10 over 3 times 1/2. So that's 10 over 6. Anytime you take a fraction and divide it by 2, all you have to do is double the denominator. And that cuts that fraction in half. Okay? So, 10 over 3 divided by 2 is 10 over 6. And then you square it, and that's 100 over 36. But if you don't remember how to do this, just take your calculator and do 10 divided by 3. Get that answer, divide it by 2, change it back to a fraction, it'll give you 10 over 6. And then square it. That'll be 100 over 36. Okay? So that's your C. Now, to write that, as my binomial squares, what's my first term?
X
Plus or minus?
plus.
What? 10 over 6. B divided by 2. It's x plus or minus your b divided by 2, which we already determined was 10 over 6. Okay? So be careful with the ones that are fractions. Also, when you're solving these, after you complete the square, if you end up with a negative underneath the square root, take out an I. Your answer is going to be a real number plus or minus an imaginary number. Okay, so for your homework, page 286, 24 through 52, every other even. So you do 24, you skip 26. You do 28, you skip 30. You do 32, you skip 34. 55 through 60 all, and then these last 5 problems are where you're putting them in vertex form. Okay, the rest of them are, the first set, you're either just finding C or just writing the binomial square. Your second set, you're solving, and this one you're putting in vertex form.